I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss the lesson on the inverse of quadratic functions. We'll begin with the given function, which is minus 4 plus x minus 1 whole square, to illustrate how do we sketch the graph of the function, how do we sketch the graph of inverse of the function, and then we are going to discuss domain and range. Algebraically, we'll also find the inverse and evaluate some values and also an expression for the inverse function. We'll also see how can we make inverse of a quadratic function a function by posing some restrictions, and at the end we'll have the next question for you to practice. So let's begin with the graph of the function itself. So we have this graph paper for you, and we'll try to sketch the graph of the function f of x equals to minus 4 plus x minus 1 whole square. Well, most of you know it, but just for the continuation, it's a recap. So we have this function f of x, which is equal to minus 4 plus x minus 1 whole square. Normally, you will write this as x minus 1 whole square minus 4, correct? Now, from this function, you know what is the vertex. Well, the vertex, I'm saying v, will be 1 minus 4. So on the coordinate plane, let's have 1 minus 4 as the vertex. So that's the vertex for us. Clear? So first thing is plot the vertex. Now, what you could do is that you could take out some values for x and then calculate f, the function value, right? You could do that. But here, I'll illustrate the step method to you to sketch the graph, which is known to some students, right? Step method. Step method is that always a parabola, the steps will be in the ratio of 1, 3, 5, 7, and so on, right? Now this is multiplied by a, and a in this case is 1. So it will be 1, 3, 5, 7 in this particular case. So normally it's multiplied by a, but a is equal to 1 for this particular parabola. So the steps will be, let me take a lighter color here. So if I move 1 unit to the right, then we go up 1 unit, correct? So that is what it is. The vertex is always on the axis of symmetry, so the other point will be on the other side. Next time, if I move 1 step, then I move 3 up. 1, 2, and 3. We are reaching the x-intercept. Now here we have the x-intercept, therefore at minus 1. So you see that 1, 3, and then 5 will be one more step. 1, 2, 3, 4, 5, right on the top. So carefully, I have selected this particular function so that we could give you a very good graph and then discuss it later. So we get a parabola, as you can see, which this point will be here, which I can connect with a smooth curve, right? And that's what is a parabola is. So smooth curve really means that this portion is not like a vertex, right? It's a smooth turning point, right? So you could go like this and then sketch a parabola. Do you see this? Like that, you could sketch it, correct? So let me bring it down from here and connect it, right? So that is how we have sketched the function, right? Which is definitely a parabola. At this stage, whenever you're working on inverse of a function, it's a good idea to write down domain and range, right? So let's write down the domain of this particular function, which, as you know, is all real numbers, right? For any parabola, for that matter, right? So the range will be what? Well, the range is y belongs to real numbers. However, y is greater than equal to, in this case, a minimum value of minus 4. Since the parabola opens up, we have a minimum, right? So we have a minimum at the vertex. So we have domain range of our function. We have also seen that the x-intercepts from the graph were at -1 and 3. The axis being at x equals to 1. So we have done the first part of sketching the graph, and now let's focus on how do we sketch the inverse of the function, correct? Okay, so now let's sketch the inverse of this particular function. Now, for inverse, you know the x and y points really swap, right? So basically the idea is that if I have x, y points on the function itself, we swap them and we get the inverse, right? So let's begin with the vertex itself. So we know vertex is 1 minus 4. So if I swap this, in that case, the image of the vertex, which is 1 minus 4, will be what? Well, let's swap this and let's call this as v prime, right? So it'd be -4, 1, correct? So that means at -4, we'll have a value of 1. So that becomes the vertex now, right? So if this was v for us, that is what we are calling the image, correct? Okay. Now, we could also swap these x-intercepts. We have -1, 0, right? So -1, 0 if you swap, then you get what? You get 0 minus 1. So we get 0 minus 1. And the other one, which is 3, 0, right? So this is 3, 0. So it will swap to 0, 3. So you get the other one there, correct? So swap x-intercepts. So which, as you can see here, were -1, 0. So that goes to 0 minus 1. And also we had at 3, 0. So that goes to 0, 3. Makes sense, correct? How easy it is. Do you see that? So now again we can actually draw this parabola, but this time opening in the direction of the right direction. Is it clear to you, right? So I have sketched this, and that becomes the inverse of this particular parabola. Do you see how easy it is? Just by swapping the important key points, we actually got a parabola. Well, you could use many other points also to swap and get a more accurate result. However, the idea here is to share with you how easy it can be, right? So just follow these steps. Let me once again summarize what we did here. For the function, we identified the vertex, right? And then we sketched the parabola using the steps of 1, 3, 5, 7, since the value of a, the vertical stretch factor, is 1, right? So it's like x square graph, which is shifted 1 unit to the right and 4 unit down. So it is exactly like x square graph, but translated 1 unit right and 4 down. Perfect. And then to find the key points for inverse function, we swapped x and y values and connected them with another parabola, which is now opening to the right side. So inverse of a parabola which opens up will be a parabola which opens on the right hand side. Well, you better know this as a square root function, right? So upper half is plus square root something and lower half is minus square root. Perfect. Now, let's write down the domain and range of the inverse function. Of course, they swap, right? So in this case, for the inverse, I'm writing f minus 1. Inverse, we see now that the domain basically becomes what? Well, the domain swaps, and you can see that domain is on the right side of -4. So domain is x belongs to real numbers, where x is greater than equal to -4, correct? And the range for this is what? Well, range is y belongs to all real numbers. Makes sense. So in this short space and short time, we have discussed complete concept of how do we sketch inverse of a parabola given in the vertex form. Well, if you are given in the standard form, then what will you do? Well, very clear. If I give you equation as y equals to ax square plus bx plus c, then convert it to the vertex form, right? Then you have to write this into the form x minus p whole square plus q. And that you can do by completing the squares method. So in case you need help with completing the square methods, I'll provide you a link, and there are many videos on my playlist which can help you do so. So once you get the vertex form, now you see how easy it is to sketch the parabolas. It's kind of important to understand that given in any other form, you should come back to the vertex form and then sketch inverse from the graph. Clear? Okay, so that's done. Now, let's discuss further with the help of the graph. So this time what I have is that we actually have the good graphs already sketched for you, which we're talking about. So as we saw that we have original graph whose function has a vertex at 1 minus 4, right? So that is the vertex. So let me write this. This is the function f of x, and the inverse of that is this function. Is that clear to you, right? Now the idea here is to see that the inverse is not a function, right? So inverse is not a function. Clearly it is not a function, since if I draw a vertical line, as you can see, it crosses at more than one point, right? So that is why it is not a function. Now the question here is, how to restrict functions to ensure that inverse is also a function. Now that is important test question, correct? Very important test question. So clearly what we could do is that we could just check one side of the parabola. You get the idea. So if I consider that x is always greater than, let me write greater than, equal to here 1, right? So if I restrict domain to x greater than equal to 1, in that case we are looking at only the right side of the parabola, correct? And so if you are looking at the right side of the parabola, in that case the inverse will be the upper side of the parabola opening right. Do you see that? And that will ensure that inverse is a function. So you get the idea. So what we did really here is to restrict domain. Of the function itself, right? So we did x greater than equal to 1. So why? So this is because it is the axis, right? So take one side of the axis. You could take left side also. Perfect. So restrict domain. So once you do that, in that case, we get the inverse also as a function, which is upper square root, right? Graph. Is that clear to you, right? As shown here. So I hope this concept is also clear to you, that the inverse of a quadratic function is never a function, right? It will fail the vertical line test. So the quadratic function actually fails the horizontal line test, right? So if I draw a horizontal line, it crosses at 2 points. Since the quadratic function fails horizontal line test, its inverse will fail the vertical line test, and therefore the inverse will not be a function. Clear, right? Okay. Now let's look into the next part of it, and that is how do we actually, so we have already seen the restriction part, right? So next, let us see how do we find the inverse algebraically, right? So now let's find inverse algebraically. Correct? So last time we actually graphed the inverse directly, correct? Now we will find inverse algebraically. So when you do that, of course, we have to swap x and y and then isolate y, correct? So that is the first step, swap x and y, right? So let's do that. So we have this equation, which is y equals to minus 4 plus x minus 1 square. So if the function is given to you in function notation, right, f of x as y, right, and then you swap, correct? So let's swap it now. So we get x equals to minus 4 plus y minus 1 whole square. Now we need to isolate y, right? Correct. So bring 4 to the other side. So it becomes x plus 4 equals to y minus 1 whole square. And then, of course, we'll square root with plus and minus, correct? So we get this, which is y minus 1. And bringing 1, we get 1 plus minus square root of x plus 4, correct? Which is y. Correct. And therefore, we can now write down the inverse of this particular function, which is f inverse. I'm not using x here because it is not a function, right? It is 1 plus minus square root of x plus y, correct? Now that is plus and this is minus, right? So the equation for these, as we just derived, is for the lower half, it is 1 minus square root of x plus 4, correct? That is 4, not y. Okay, and the upper half is 1 plus square root of x plus 4, correct? If you would have restricted, then you can now see how each half corresponds to one another. Perfect. Okay, so we got the inverse of this particular function as we wanted, correct? Now, in this particular case, once we have the inverse, you can actually relate many points and review. Now, the exercise for you is to find the values, right? So, can you evaluate what is f inverse of, let us say, 5, right? So if I want to evaluate f inverse of 5, I'll basically substitute x as 5, right? So I'll have 1 plus minus square root of 5 plus 4, right? Which is 9. So I get 1 plus minus square root of 9, which is 1 plus minus 3, right? And what do I get? I get 1 plus 3 as 4 and 1 minus 3 as minus 2. You get the idea. So at 5, we get two values, and which is 4 and minus 2. So you see, if I take up this particular line of the inverse function, right? So you can see clearly that we have these 2 points, right, at 5 on the inverse function. So you see that. So we can now evaluate the f inverse 5 and get these kinds of points, right? So any value you could do it, correct? So I think now you understand first how do we find the inverse using the graph, and then how do you find inverse algebraically, and then how do you find the values on the inverse function. Well, as an exercise, you could also calculate some more values, right? Okay. Now I hope you got the concept. I'd like you to do this particular question where you are given f of x is minus 8 plus 2 times x minus 1 whole square. I've taken a question which is very similar to our example. You need to find when is f of x equals to 0. That means the x-intercepts, right? F inverse of minus 6 and an expression kind of f inverse of 2a minus 8 for this particular question. So I hope this practice question will help you understand what we just did in this video. Perfect. So that's great. So I think we have done all these things. Now here's one more question, which is f inverse of 3a minus 4, which we need to figure out. So that remains a question for you. Evaluate f inverse of 3a minus 4. Now I'll also show you how do we find inverse of a function using words, right? So we'll use words to find inverse. So I'm going to extend this. So words means that the function itself is evaluated when you do x, you take away 1, square it, and then subtract 4, right? Reverse operation. So we'll use reverse operations. Reverse operation is you add 4, right? Square root and then add 1, correct? So we get the inverse of this as x, you add 4, correct? And then you square root, correct? And then you do plus and minus, and then you add 1. See how easily we got the inverse of this particular function. I actually did it so that I could evaluate 3a minus 4 and show you how it looks like. So let's find the inverse 3a minus 4. It's a test question, right? So just plug in 3a minus 4 for x. So 3a minus 4. We already have plus 4 within the square root, right? We get plus 1, right? and this is plus and minus, correct? So what we get here is 3a minus 4 plus 1 is 0. So we get square root of 3a, right, with plus and minus outside, plus 1. So basically, you could write this as 1 plus minus square root of 3a. So that is the expression for the inverse at 3a minus 4. You see that. So you could also evaluate expressions once you have the algebraic value of the inverse of the function. So with that, we conclude. I hope it was interesting and useful for you. Feel free to write your comments and share your views. In case you like and subscribe my videos, that'd be great. And if you want to learn from me directly, you can always send an email on the address given. Thanks for your time and all the best.